Right now, above your head, there are somewhere between 1 and 2 trillion galaxies, each one holding on average 100 billion stars. That's not a rough guess. That's the conservative number. Multiply it out. And the number of planets in the observable universe is bigger than every grain of sand on every beach on this planet. And out of all of that, we've found one place with a pulse. One. If the numbers are right, that shouldn't be possible. The universe should be loud. Instead, for over 60 years, we've pointed our best instruments at the sky and heard exactly nothing. That silence isn't just strange, it might be the most important data point in all of science. In the summer of 1950, physicist Enrico Fermi was having lunch with a few colleagues. They were joking around about aliens, flying saucers, that kind of thing. Then Fermi went quiet for a second and asked one simple question. Where is everybody? He wasn't being funny. He'd basically run the numbers in his head, and the numbers said the galaxy should already be full, colonized, buzzing. That gap between how likely alien life looks on paper and how absent it seems in reality is what we now call the Fermi Paradox. Stick with me, because once you actually sit with this question, it stops feeling like science fiction. It starts feeling personal. Let's start with the case for aliens, because on paper, it's overwhelming. Take our galaxy. The Milky Way holds somewhere around 200 billion stars. In the last 30 years, we've confirmed more than 6,000 planets orbiting other stars, with thousands more candidates waiting to be verified. And that's just the ones close enough and angled right for us to notice. Scientists think our galaxy alone could hold hundreds of billions of planets we'll simply never see. Now zoom out, multiply that by somewhere between 1 and 2 trillion other galaxies. You're no longer talking about millions of chances for life. You're talking about a number too big for your brain to actually picture. Here's a way to feel the scale of it. Say you're deeply pessimistic. You think only 1 in a million planets could ever develop life. Sounds safe, careful even, but plug that tiny probability into numbers this large, and you still walk away with more living worlds than you could ever finish counting. This is the logic behind something called the Drake equation. It's just a chain of odds. How many stars form? How many have planets? How many of those planets could support life? How many of those get smart enough to build something like a radio telescope? It's not meant to spit out an exact number. It's meant to prove a point. Even with harsh, pessimistic guesses at every single step, the universe should not be this quiet. So the obvious assumption, the one built into every alien movie you've ever seen, is that we are nowhere near alone. Statistically, we shouldn't even count as rare. We should be background noise. So here's where it stops being comforting. If intelligent life really is that common, some of it should be old. Our sun is about 4.5 billion years old, but the universe is over 3 times older than that, which means somewhere out there, a civilization could have gotten a head start on us, not by centuries, by millions, maybe billions of years. And here's the part that really breaks people's brains, that head start doesn't need to be huge to matter. Imagine a civilization builds one simple machine, a probe that can fly to a nearby star, land, and use raw material to build a copy of itself. Then those two build 2 more, then 4. This isn't fantasy. The underlying idea comes from a real mathematician, John von Neumann, and his work on self-replicating machines. Run the math, and even a slow version of that probe could spread across an entire galaxy in a few tens of millions of years. On a 13 billion year clock, that's not slow, that's basically instant. So if even one civilization got that kind of head start anywhere in the last few billion years, the galaxy should already show it. Alien radio chatter leaking into space the way our own TV and radar signals leak out. Something scientists call a Dyson sphere, basically a shell of energy collectors built to wrap an entire star, which would show up as strange excess heat pouring off a star that's had its light partially captured, some kind of fingerprint, something. Instead, over 60 years of specifically listening, and we've heard nothing, not a whisper. That's not a small gap between what we expected and what we found. That's a chasm. And that chasm is exactly what turns the Fermi Paradox from a fun thought experiment into a real, unresolved scientific problem. Here's where most people's assumptions get flipped upside down. There's an idea first proposed by economist Robin Hanson called the Great Filter. And once you understand it, you can't unsee it. The idea is simple. Somewhere between lifeless chemistry and civilization that spreads across the stars, there's a step that's almost impossible to survive. A filter. And the unsettling question is, where does that filter sit? Behind us or ahead of us? If it's behind us, that's genuinely good news. It means whatever's nearly impossible, maybe the jump from simple cells to complex ones, maybe the origin of life itself, we already got through it. We're rare, borderline miraculous, and the silence just means we're early, or alone, or both. But if the filter is still ahead of us, that's the version nobody wants to sit with. It would mean every civilization gets exactly this far. Curious, technological, looking up and asking questions right before something ends them. Nuclear war, runaway climate collapse, artificial intelligence nobody can control. Some trap built into the very nature of intelligence that every civilization walks into on its way out the door, and there's an even darker layer underneath that. It's called the Dark Forest Hypothesis, and the name comes from a science fiction novel, but the logic underneath it is real game theory. The idea the universe isn't empty, it's just silent on purpose. If you have no way of knowing whether another civilization is friendly or hostile, announcing your location isn't brave, it's reckless. So maybe everyone's out there, listening, hiding, staying quiet for the exact same reason we might want to. Not because there's nothing to say, but because saying it might be the last thing you ever do. So which is it? Are we early? Are we rare? Or are we just quiet like everyone else, hiding in the dark for a very good reason? Here's the honest truth, we don't know. And in a strange way, that not knowing says something about being human. We're the species that looked out at an incomprehensibly vast, silent universe. And instead of looking away, we built telescopes. We started listening. We asked the question anyway, even knowing we might not survive the answer. Maybe the silence isn't empty at all. Maybe it's just a held breath. Ours, and maybe everyone else's too. We've spent this whole video asking, is anyone out there? But maybe that's the wrong question. Maybe the real one is this. If you knew with total certainty that something out there was listening, would you still want to say hello? Let me know what you think in the comments, and give me a like if you liked the video.